Hello, this is Coach Holmes, and the next thing we're going to talk about is distance formula. Now, what distance formula tells us or does is to help us to find the distance between two coordinate points on a graph. Okay, so that's what the big difference is between the distance formula and the segment addition postulate. Is that with the segment addition postulate, we're looking at segments, okay, but that's not on the graph. Distance formula is going to help us when it comes to a graph. Okay, so what is the distance formula? Well, it's a simple formula where d is equal to the square root of x2 minus x1 squared. Let me write that x a little bit better. Plus y2 minus y1 squared. All that in the square root. That's what distance formula tells us. Okay? So, just to get a good idea of what we're talking about. So let's say I have these 2 points here. Okay? So let's say this is x1, y1. And this is x2, y2. Okay? So I have those 2 points. What it really comes from, what this actually comes from, it comes from Pythagorean theorem. And if you remember, it's a squared plus b squared equals c squared. And if you don't believe me, just watch. So let's say I'm going to make a horizontal line. I make a horizontal line right here, and I make a vertical line right here. Well, I basically just form a right triangle. And with a right triangle, I can actually use Pythagorean theorem because that's what Pythagorean theorem is used for. It's used for right triangles. Now, however, if you look from these 2 points, this is the difference between my x's. So I know that this is going to be x2 minus x1. And this right here, where it's vertical, that's the difference between my y's. So this is where it's going to be y2 minus y1. Now I will, that's a 2. Okay? So that's where distance formula is coming from. That's where we get the distance formula. If we just break it down and realize, well, this is the difference between my x's, this is the difference between my y's, square both of them, add them together, and take the square root of that. Okay? At least that's where it comes from. Now, how does it work? Let me show you. So let's say I have a sample on a graph. So let's say these 2 points, let's say I have these 2 points at 2, 3, and 4, negative 1. Okay, so I'm going to rewrite those points real quick. Okay, so I rewrote the points. Okay, so now I'm going to write the distance formula. So d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so now I just got to be able to figure out what x2 and x1 is. Well, I'm here to tell you that it makes no difference which one is which. The 2 could be x2, the 4 could be x1, or vice versa. However, if I make this x1, for example, I have to make this y1. If I make this x2, I need to make this y2. Because if I flip-flop both of them, whereas this is x1, y2, x1, y2, then I'm going to mess up the problem. I'm going to mess it up. So I'm going to label it accordingly, like this. So my x2, I know x2 is going to be 4. Minus x1 is 2. Plus y2 is negative 1 minus y1 is 3 squared. Now, 4 minus 2, so remember, so in order to work this out, I gotta be able to use order operations, or PEMDAS. First thing with PEMDAS is parentheses. So 4 minus 2 is simply 2. I gotta work out this parentheses as well. Negative 1 minus 3 is negative 4. Now, after I get done with the parentheses, I gotta use my exponents. So I got two exponents here. I got 2 squared and a negative 4 squared. Well, 2 squared is going to give me 4. Plus, negative 4 squared is a positive 16. Because remember, a negative times a negative gives me a positive. So negative 4 times negative 4 gives me a positive 16. So next, 4 plus 16 is going to give me 20. So the distance is the square root of 20, whatever it comes out to be. Now, let's say they give us coordinates. So let's say instead of giving us a graph, let's say they give us coordinates. So I got a coordinate of point A at negative 5, 2, a coordinate B at 7, 6. And I'm just going to rewrite the distance formula real quick. Okay? Remember, what I can do is I can label each of these points accordingly. So for example, I can make this top x2, y2, and I can make a bottom x1, y1. Again, it doesn't matter which one's x2, y2, and which one's x1, y1. Okay? Just as long as the x1 is paired with the y1, and the x2 is paired with the y2. Okay? Just remember that. Now, I'm going to replace the x2 with negative 5. x1 is replaced with 7 squared plus y2 is 2 minus y1 is 6 squared. So now I'm going to take negative 5 minus 7, because remember that's parentheses first, to make it negative 12. Plus 2 minus 4 is negative 4 squared. Now, all I gotta do is just square both of them. I know that the negative 12 squared is going to give me 144. Plus negative 4 squared is 16. And remember, they're both positive because the square is basically taking the negative times the negative again. Because remember, square tells me that I'm multiplying itself 2 times. So 144 plus 16 is going to give me 160, the square root of 160. Let me rewrite that like that. There we go. So that's going to be my answer, the square root of 160. So whenever we're trying to find the distance by using the distance formula, we just got to keep in mind that x1 has to pair it up with y1, x2 has to pair it up with y2 as far as labeling goes. Okay? Because as long as you label the right numbers accordingly, you plug the values in and then be able to use PEMDAS in order to find the distance. Okay? That's how we're going to use distance formula. Just remember, label accordingly, plug the values in, and use PEMDAS in order to help you find the distance. Okay? Thank you and have a good day.